only a month before MIT had found that there was superconductivity in Twistronic graphene at a degree of 1.1 degree.
What sparked the interest in advanced material manufacturing, or deep tech as one would say?
We were forced to do a mandatory business course, a business commercialization of research. And at first I was really against it. I thought, actually, this is really interesting, because I wanted something more thrilling, more exciting, and I also wanted something where I was connected to STEM again. When I started at Atlant 3D, all those things that I learned about corporate governance, processes, I transferred that to startup. We have an atomic layer manufacturing platform that enables the future of electronics, photonics, and materials innovation. One of the first ones we did was a project, a space manufacturing project for NASA, because there is interest and demand for in-space manufacturing. So we own the hardware, software, and gas recipe IP, and that process can immediately scale to industrial manufacturing. Materials discovery and screening and optimization of materials is automated, and this AI system learns from it. You're flooding entire chambers with material, and most of it is not needed and is wasted. He's never like, oh, these people in the commercial team, you need to do better. It's an us. In the quantum industry, it's anyone's getting, the underdogs, the companies that don't even exist yet. People always want to help, but not very many people ask for help because they think people don't care. That's what I'd be most proud of if I were retiring.
Today, we speak with Dr. Bonnie Tsim, Head of Strategic Initiatives and Growth at Atlant 3D, a visionary integrating cutting-edge science with market strategy.
Leveraging her PhD and deep knowledge of advanced materials like Twistronic graphene, Bonnie possesses unique expertise in deep tech commercialization. At Atlant 3D, she is instrumental in driving strategic partnerships and scaling innovative direct write and atomic scale 3D printing technologies.
Prepare for an insightful discussion on how her leadership translates complex scientific advancements into tangible industrial solutions. Let's dive in.
Hello, and welcome back to the Semiconductor Leadership Podcast. I'm your host, Salah Nasri, and it is with great pleasure to bring you a very special edition today. So, whether you're an industry veteran or someone that's just curious about semiconductor manufacturing, this is your podcast. But before I start this episode, the platform has now hit 100,000 views, but we have 2,500 subscribers. So yes, I need a small favor. Click on that subscribe button just down here. Now, without further ado, it is with great pleasure to welcome Bonnie Tsim, and I'll have to add a specific, what would one say, word? Dr. Bonnie Tsim, who is the Head of Strategic Initiatives and Growth at Atlant 3D. Bonnie, welcome to the show.
Thank you.
Do you want me to call you Bonnie, or do I want Dr. Tsim, Dr. Bonnie?
You can call me.
Sure? You don't want me to call you Dr. Bonnie? No. Dr. Tsim? All right, Bonnie, thanks for coming in. Could you share a brief overview of your path from researching, and this is the first time I ever heard this, is Twistronic graphene? Can you give us an explanation of what is Twistronic graphene?
Of course. So my background is in theoretical physics, specifically modeling electronic properties of Twistronic graphene. So for those that don't know what that is, so graphene is a layer of carbon atoms arranged in a honeycomb lattice. And Twistronic graphene is where you have two layers of graphene on top of each other, twisted by an angle. And when I started my PhD research project in April 2018, only a month before, MIT had found that there was superconductivity in Twistronic graphene at a degree of 1.1 degree. So my professor at the time basically said, okay, that's your research project now. And I started modeling Twistronic graphene at different angles to see what those differences were.
Marvelous. And what's interesting is that you did it. Actually, loved the place. I've been there before. The University of Manchester. How was that experience?
Incredible experience.
Okay.
So University of Manchester has the National Graphene Institute. So at the time, so in 2010, Sir Andrei Geim and Sir Kostya Novoselov, they won the Nobel Prize in graphene. So it was really amazing to be able to collaborate with their experimental group and their students. And Manchester itself is a really bustling city. And it was a really great vibe, great for learning and great for living as well.
Wow, marvelous. So the interesting point is that everything is sparked from somewhere. So from your perspective, what sparked the interest in advanced material manufacturing, or deep tech, as one would say?
Yes. So I'd say my interest in 2D materials and advanced materials started when I was around 20. I had an incredible lecturer called Dr. John Wallbank. And funnily enough, what he was teaching was not actually materials, but he was such an engaging lecturer that I went to his office hours and asked him, what is your research on? And that's when he started telling me about graphene. This is what I do for my research. And in the end, my professor for my PhD was actually my lecturer's professor several years before. So I think it really sparked from that.
Marvelous. So run through me the process. So you've just finished your PhD. What happened after?
Yeah.
And how did it go?
So I finished my PhD, and when I was doing my PhD, I was like, I'm going to be a professor. I'd already mapped out, I'm going to apply for these fellowships, do this, go to Japan and all these things. And we were forced to do a mandatory business course, a business commercialization of research. And at first I was really against it. I was like, I'm doing my PhD. I want to focus on research. Why do I have to meet these industry people, consultants, and all these other people? And during that time, we, learned about business models. We did pitching, and I thought, actually, this is really interesting. And I met so many industry experts who had a PhD in STEM and who went on to do other careers. So towards the end of my PhD, I was recruited to join an association called Matter. And this association was about advancing exponential technologies like advanced materials, semiconductors, quantum technologies. And it was a for-profit think tank for, convening. It could be government, corporate, academia, startups. And I joined, and I was there for around 2 years and created this event called PuzzleX in Barcelona. And then from there, people said to me, everyone should try corporate. Everyone should experience the rat race. You learn so much with company politics, with people. So I joined corporate consulting in the construction industry for 2 years after. It was a completely different domain. I was completely out of STEM. And my current CEO, Maxim, I had met him at an event, the one that I created at PuzzleX, and he reached out to me on LinkedIn and was like, how's your job going? We have a position at Atlant 3D. And then I was ready to go from corporate to startup.
Wow.
Yes.
Why did you do that?
Because I wanted something more thrilling, more exciting, and I also wanted something where I was connected to STEM again. So in corporate, I learned a lot, but the most things that I learned were around people politics. It's not about what you're saying, it's how you communicate with these senior decision makers. And even things like, what do you write on a PowerPoint? These were the key lessons that I learned in corporate, but I really missed STEM and innovation. And I saw Atlant 3D is a growing company, now around 40 people. And I felt that it was a really good opportunity to challenge myself, where I can do what I'm best at, which is connecting people, forming partnerships. And that's what I was lacking in corporate.
Well, so you made that transition from corporate to startup. What's your biggest takeaway from the whole experience?
I would say that I appreciated my corporate experience after I left. So when I was in corporate, it was like, oh, why am I felt like I was stuck on this hamster wheel. Oh, this is a little dull. It's a little boring. And then afterwards, when I started at Atlant 3D, all those things that I learned about corporate governance, processes, I transferred that to startup, and it's actually a growing company. Sometimes you do need some structure.
Right.
And that's what I learned.
So now you're at Atlant 3D. For the listeners who are not aware of Atlant 3D, what's Atlant 3D?
So Atlant 3D, we're an innovative deep tech company, and we have an atomic layer manufacturing platform that enables the future of electronics, photonics, and materials innovation. So our patented technology enables us to directly deposit onto materials in real time with less process steps compared to traditional manufacturing methods.
And what does it mean from your side to be head of strategic initiatives and growth at Atlant 3D?
Yes. So part of my role is to identify new opportunities. So this could be geographic partnerships, looking at how we enter new regions, for example, in UAE or America. But it also means forming partnerships with academia, institutions, and industry as well. So it's about, finding new applications for our technology and new things that we can do as well.
So what would be interesting to understand is that based on all that what you studied during your PhD and your background in theoretical physics, as one would say, with the company's focus in specific to Atlant 3D on micro and nano manufacturing solutions, how have you bridged both of them?
I'd say the way I've bridged it is when you're forming partnerships, especially, for example, with governments or nonprofits, it's very important to be able to communicate the science in a way that is relevant. And this could be about driving the economy. It could be about driving sustainability. So I'd say that I bridge between, okay, this is what is important in the science, and this is how it's relevant to you, and this is how it benefits the country, for example.
I see. So looking at Atlant 3D's mission, which is quite a revolutionary solution that you guys are working on, especially the DALP tool that you're specifically working on. What I would be interested to know would be if you could give us a snapshot of Atlant 3D's, if you can share, most exciting projects or potential industry impact that you guys are working on.
Yes, for sure. So the company started in 2018, and after we filed our patents, so the technology we have is DELP, so that means direct atomic layer processing. We started seeking out different pilot projects. So, for example, one of the first ones we did was a project, a space manufacturing project for NASA, because there is interest and demand for in-space manufacturing. Recently, we've also finished a prototype with European Space Agency where we have a platform that can do in-space manufacturing. And this is relevant because when you're in space, let's say you have broken devices, you need to be able to repair it rather than, wait for parts to be sent to the moon or sent into orbit. So those are quite interesting. We're also exploring other domains as well. So, for example, sensors in the automotive industry. And recently, we're now exploring advanced packaging in semiconductors because with our technology, we can do localized atomic layer processing. So we're thinking, okay, our technology is already more sustainable because we use less material. How can we apply that to the semiconductor industry?
Do you feel, when you look at the landscape in terms of competitive landscape that you're involved in, especially in the equipment world, what would you say is that the biggest differentiator for Atlant 3D?
I think the biggest differentiator is that we have a lab-to-fab solution. So in conventional atomic layer deposition, you need to fill an entire gas chamber with gases and then you purge. So that means that if you want to deposit atomic layers on a bigger substrate, then you need a bigger chamber. And then that whole recipe, everything you've optimized, the parameters, has changed. In our solution, it's modular. So what we do, for example, on a 4-inch wafer, that can be directly scaled. So we own the hardware, software, and gas recipe IP, and that process can immediately scale to industrial manufacturing. So that is the biggest differentiator. We can go from lab to fab.
Remarkable. So if we look at it from that perspective, going from lab to fab, I mean, where do you see specific challenges that could arise from doing that, and how are you guys working on overcoming those specific problems?
Mm-hmm. So I think what the industry is demanding is that our tools fit seamlessly into existing processes. So we're on our roadmap, we're working on a cluster tool that can easily integrate with existing processes. And I think that will give the supply chain a lot of confidence. I think sometimes there may be resistance in new tools, and especially when it's not like, oh, I have a printer, I want to replace a printer. Part of it is also an educational process. Allowing people to understand, what this technology actually means and how it can integrate seamlessly into their processes. So I think the educational angle, that could be a challenge as well.
Now, when we look at, of course, all these great technologies that we're working on as a community, from a whole supply chain perspective, what would be interesting to understand is that there's a cross-industry relevance associated. Now, of course, with the technologies that you guys are working on, which will directly have an impact on healthcare or automotive or AI or even quantum computing, which applications are you most excited about and why?
I think from my materials science background, it's materials discovery, and not only materials discovery by itself, but AI-driven materials discovery. So with our platform, I see a vision where materials discovery and screening and optimization of materials is automated. So imagine, you've got this AI chatbot, you deposit material, and then this is characterized in real time, and this AI system learns from it and is like, okay, immediately we should deposit this thickness instead. And then this is a recurring cycle, and everything in the world is driven by materials. So I think AI is booming now, and materials, the importance of materials innovation shouldn't be understated. So I think this is most exciting for me.
Now, in your view, and with AI, I'd like to go a little bit deeper in terms of understanding what are the current bottlenecks that the advanced materials sector is facing today.
Yes. So normally for advanced materials, let's say we wanted to test different thicknesses of materials, you would have to do this in multiple process steps over many wafers.
Right.
Whereas with our technology, we're able to deposit different thicknesses onto the same wafer in a single process step. And that's really powerful because we can direct write onto a wafer rather than do shadow masking, lithography, etching, which really extends not only the time, but also the cost. And also existing materials innovation processes are not very sustainable because you're flooding entire chambers with material and most of it is not needed and is wasted.
Right. Thank you for that explanation. So I want to go into the leadership perspective and future outlook. From your perspective and from a small startup that you're involved in, which will one day be a very large company, I'd like to understand there are two different ways companies are, you got small size, mid size, and large size, large cap. And each of them have a different type of culture.
Yes.
How are you and your colleagues and your team with your CEO are fostering a culture of innovation?
It's speed.
Okay.
We use Teams a lot, and it's really important that when you don't understand something, to be comfortable dropping a message and saying, hey, I don't understand this. Could someone explain it to me? And our CEO does the same. He's like, hey, I don't understand this. Could someone please help me? I think it's really important to understand that you're not supposed to know everything. And even those in the C-suite and leadership positions, we don't know everything. And we all come with different experiences. Also, within our company, we're around 40 people at the moment with over 20 nationalities. So for us, it's understanding that we all communicate differently, whether that's due to culture or language. And we always, our CEO always says, look, if someone crosses a boundary, you just say like, hey, that's not okay. Like maybe it's a joke, but because some people, we don't know, right? We all have different ways of upbringing. So I think that really fosters a culture of closeness as well, and also innovation, because we can be direct and blunt with each other.
Yeah. Thank you for that. So another key thing is I would love to ask you is like the camaraderie at Atlant 3D. It's I think your CEO's implemented this culture of camaraderie, which stands out very, very clear. How has he done that? How has he made that happen?
He always says the company it's a we.
Okay.
And especially when we're in meetings, he's never like, oh, these people in the commercial team, you need to do better. Or, people in applications, he's always like, no, it's an us. If we have a problem, it's an us problem.
Right.
And it's the language he uses. It's subtle, but he's always saying like, look, we need to do this, or, oh, we did this really well. And I think that matters, because it's not like I think this or you did that. It's, we're all in this together. And he's always making a point that, let's say, if something is underperforming, he's never like, oh, it's this one person. It's like, okay, well, how come the rest of the team didn't notice and, help the person?
Fair. So now I want to dig in terms of the future, right? Looking into 5 to 10 years ahead, Bonnie, from your side, how do you see technologies that you're working in the nanomanufacturing world, AI-driven design, and potentially quantum as well being involved, impacting the evolution of materials and semiconductors?
That's a really great question. I think quantum is an interesting one, because nobody has the answer. And what I like about the quantum industry, it's, there's some other industries where we can say, yeah, these are the biggest players, these are the biggest OEMs, everyone's competing. But in the quantum industry, it's anyone's getting, the underdogs, the companies that don't even exist yet.
Right.
And so I think that's an opportunity for people to go into, because it's new for everyone.
How do you think it'll impact the world, quantum?
Oh, I don't know. That's like asking how AI will impact the world. I'd like to think that a booming quantum will bring deep tech more into the public eye. I think at the moment, it's not like in everyday language where people, people are talking about AI. And I'd really like to see, advanced materials, quantum computing be something that, the everyday person finds fascinating.
And talking about now, what is it for others that are looking to follow the same footsteps as you, Bonnie? What do you dislike about the job?
Oh, that's a really great question. Sometimes, the job I have is exactly what I wanted. I wanted some travel, I wanted fast pace, but sometimes things come all at once and it can seem really busy. And I remind myself, I'm grateful. This is what I wanted. And it is so easy to be like, oh, I don't want to do this anymore because of X, Y, Z. But on the bigger picture, when you speak to anyone in the workforce, everyone has to do admin. Everyone has emails. So, understand that this is part of the role and remind yourself why you chose to be in that position in the first place.
I love that answer. Very well answered. What is it that you love about your job?
I love that everything's exciting. Advanced packaging, this only came to us around a couple of months ago. Tomorrow, there could be a new opportunity. Sometimes you go to a new conference and there's a new concept. It's like, oh, we should look at that. So I love that it has the scientific aspect to the job without me being in the lab or without me doing the code.
It is an exciting time to be in advanced packaging. It is what's powering AI. So for listeners inspired by your journey, Bunny, what advice would you give to those looking to enter the same field that you're in?
I think be open, because everything you think you want may not actually be what you want. So, a few years back, I wanted to be in academia because I thought I wanted to be in academia. But what you want, you might not even know exists. Mm-hmm. And the best way is to be open-minded, find people on the internet, reach out to them. Hey, how did you get into this role? And don't be afraid to be a beginner, because when you're reaching out to these CEOs, directors, nobody's thinking, oh, why are you talking to me? Like, you're
leave me alone.
Yeah, you're not worth my time. And the thing is, people always want to help, but not very many people ask for help because they think people don't care. But actually, the majority of people are very willing to help.
This is a very valid point. It's interesting that you're saying that, because this last podcast I just did, the person said the same thing, is that people in our industry, if you don't ask, you don't get. And people are really genuinely willing to help. Bonnie, it was an absolute pleasure to have you on the show. Is there anything else that you'd like to highlight, either about Atlant 3D's mission, your personal vision for future deep tech innovation?
I think deep tech innovation is the future. Look, software is extremely exciting, but let's be honest, the world has to power on hardware. Yeah. And for those looking for careers, this is a really exciting space. I think it's lucrative if money is the thing that drives you. But also don't only look at software. There's a lot in hardware that can be done.
There you have it. Thank you, Bonnie. Bonnie, there's a tradition that we have on this show where the last person leaves a question for the next person. And your question is you're close to retirement.
Oh.
What is the thing that you'll be so proud of what you have achieved in your career?
Oh, wow. That is a fantastic question. I think I want to embolden, especially early career people, could be students, to try new things, because you're supposed to be a beginner when you try new things. And I want to see people, reaching out to me and saying, oh, because I heard you say this, I decided to try software engineering, even though I'm an artist. So, yeah, that's what I'd be most proud of if I were retiring.
As in, you want to be, is it more like you want to be a role model, or you want to be someone that's shaping people's lives? I mean, what is it, something giving back, or in a different way?
A role model that people empower themselves to choose a path that they want. Of course, I'd love mentorship and sponsoring people and opening doors. But what I'd really love to be known for is, people get the courage themselves to be able to open the door themselves, because there is only so much that mentors and sponsors can do. You can say, hey, speak to this person, you can open the door, but people need to walk through the door themselves and get the courage. So
it's true.
Yeah. So courage is a really important theme for me.
It's true. Bonnie, thank you for joining us on the Semiconductor Leadership Podcast. Ladies and gentlemen, that is a wrap. If you want to get in contact with Bonnie and the team at Atlant 3D for more information or get to know her personally, this is her LinkedIn profile. You can click it right here and you can reach out to her and just put down SLP as the subject. So remember, it takes a village to raise a chip. So help us create that village. Click that subscribe button, follow us, and see you at the next episode. Until then, goodbye for now.